Let's graph the absolute value function. So the absolute value function is a piecewise defined function. Notice it has two parts. The output is x if x is greater than or equal to 0, and is negative x if the x's are less than 0. So let's do a t-table. So when we have the x's that are, let's put here, when the x's are greater than or equal to 0, we will have f of x equals x. All right. So this means that we're going to choose numbers that are greater than or equal to 0, like 0. Okay. Another number that is greater than or equal to 0, 1, 2, for example. So if we plugged in this number, f of 0 equals 0, right? F of 1 will equal 1. F of 2 will equal 2, and so on and so on. So if we plot this left side, so we're plotting this side when the x's are greater than or equal to x. All right, so we get 0, 0. You wanted to write this as points. 0, 0, 1, 1, 2, 2. So essentially this is this side, this part, this first piece is the identity function, right? So 0, 0, 1, 1, 2, 2. So as you can see, this side is going in this direction, right? It's going, and it's continuously going. We just stopped at 2, right? But it's continuously going and increasing. All right. But what about when the x is less than 0? What do we have then when the x is less than 0? So it says when the x's are less than 0, we're going to get negative x, right? Negative x. So what are some x's that are less than 0? Well, some x's that are less than 0 could be negative 1, but it also could be negative 0, 0, 0, 0, 0, 1. So here's what we're going to do. Always plot this point right here. Always plot this point, and just put a reminder that it is an open circle. So for 0, put open circle. And then negative 1, negative 2 are numbers that are less than 0. So we plug in 0 into f of 0, we get negative 0, which is 0, because 0 is neither negative or positive. F of negative 1 would be negative of a negative 1, which is positive 1. F of negative 2 would be negative of a negative 2, which is positive 2, and it goes on and on and on. All right, let's plot it. We got 0, 0. But remember, that's an open circle right there. All right, that piece. And then you have negative 1, 1, and then negative 2, 2. So you see where the absolute value of function gets its V shape right now, because of those two pieces of the piecewise defined function. All right, and notice that if you, for those two different pieces, look, we already got it already shaded there from the blacks, the first side. So that open circle really didn't matter, right? Because it was already shaded there. Let's go to the next one. This is a piecewise defined function. Look at this piece. This piece is quadratic, right? So already go ahead and learn your shapes of your parent function so you will know what's going on. So you know you're going to have a piece of a U-shaped function, and then this shape is linear because x is to the first power. You know it's going to be a line. So you're going to have a piece of a parabola and a piece of a line. The first piece is x squared if x is less than or equal to 1, or you can put f of x equals x squared when the x's are less than or equal to 1. And the second piece is f of x equals 2x plus 1 when the x's are greater than 1. All right, so let's do the first piece. All right, first piece, you have f of x equals x squared. Let's only put numbers that are less than or equal to 1. So 1, work will work. I always plot this point though. Whatever this is for a piecewise defined, I always start with that number, but you may have to put open circle if it doesn't have an equal sign. Put a note right by it to say open circle. But we do want to start with these numbers. All right, so 1, and then 0, and then -1 will work. And then -2 will work. So f of 1 equals 1 squared, which is 1. F of 0 equals 0 squared, which is 0. F of -1 would be -1 squared, which is 1. F of -2 would be -2 squared, which is 4. So we have these points here. If you want to write them out, 1, 1, 0, 0, -1, 1, -2, 4. So let's plot those points. In green, 1, 1, 0, 0. Look how it's going to the left. -1, 1, -2, 4. See how it's going to the left? So we're going to extend it to the left, not to the right, because we're going in the left direction. Numbers that are less than 1. Not going this direction, we're going in this direction. Numbers that are less than 1. Now, for the other piece, let's plot that in another color, like red. So what about, so this was, the first piece was when x's are less than 1. What about when the x's are greater than 1? Still start with 1, but put open circle there. It'll be 2x plus 1 this time. Greater than 1, 2, 3, 4, for example. F of 1 equals 2 times 1 plus 1, 3. F of 2 equals 2 times 2 plus 1, 5. F of 3, and this is a line, so we really don't need a extra number. We only technically need 2 points to graph a line, but we always choose 3 to check the other 2. So 2 times 3 plus 1, 7. All right, here we go. 1, 3. That's supposed to be an open circle. 1, 3. 1, 2, 3. Open circle. Or else it would not pass the vertical line test if it wasn't a open circle right here, because you gotta miss that one. This one filled in. So think about it. If it wasn't an open circle there and it was closed, it would not pass the vertical line test. Therefore, it would not even be a function. And we know these are functions because we are being asked to graph piecewise defined functions. 2, 5, 1, 2, 1, 2, 3, 4, 5. All right, so we have a line going in this direction. So we have a piece of a line in red and a piece of a parabola in green. All right, let's go to the next one. There are 3 pieces. What type of function is x plus 4? What type of piece is that piece? Okay, that piece is linear. Then the next one is quadratic. And the next one is linear again. And we know it's linear because of the degree. If the degree is 1, we have a linear function. If the degree is 2, we have a quadratic. All right, so first piece is x plus 4. Second piece is 4 minus x squared. When the x's are between 0 and 2, but including 2. First piece is when the x's are less than or equal to 0. And the last piece, negative x plus 4, when the x's are greater than 2. So you can rewrite that as greater than 2. Notice that these intervals will never overlap, or it will not be a function. All right, first piece. Let's plot f of x equals x plus 4. This is when the x's are less than or equal to 0, but still always start with that number you see. 0, for example. What is less than 0? Negative 1, negative 2. So f of 0 equals 0 plus 4, which is 4. F of negative 1 is negative 1 plus 4, which is 3. F of negative 2 equals negative 2 plus 4, which is 2. So what are those points? 0, 4, negative 1, 3, negative 2, 2. So let's plot those points. 0, 4, 1, 2, 3, 4, negative 1, 3, negative 2, 2. So we have a line going in this direction, not to the right, but to the left. Let's switch the colors up. What about the second piece? So f of x is 4 minus x squared, so that's going to be quadratic. And we're going to use these numbers that are on these boundaries here. 0, 1, 2. Now the 0 is going to be an open circle because it does not say equal to there. It's just when x's are greater than 2. All right, and less than or equal to 2. So 0 would be f of 0 equals 4 minus 0 squared, which is 4. F of 1 would be 4 minus 1 squared, which is 3. F of 2 would be 4 minus 2 squared, which is 0. So let's plot that, realizing that it's quadratic. It's not a line. It should curve somehow. 0, 4, open. So it does pass the vertical line test. 1, 3, add 2, 0. So notice it's curving upside down. All right, this is an upside down U. And then next, let's plot f of x equals negative x plus 4. But this is when the x's are greater than 2. But again, start with the number you see, 2. We just need to put open circle there. 3, 4. All right, f of 2 equals negative 2 plus 4, which equals 2. F of 3 equals negative 3 plus 4, which equals 1. F of 4 equals negative 4 plus 4, which equals 0. So this is a line, again, linear, 2, 2. So we're going to put an open circle there, or else it would not pass the vertical line test. So remember to write that note for open. 3, 1. 3, 1 is here, and 4, 0. So it's going in the right direction. So notice this graph is very ugly, but it does pass the vertical line test. All right, let's go to an application problem. It says a mechanic's pay is $14 per hour for regular time and time and a half for overtime. The weekly wage function is W of H. What do you think W stands for here? Probably weekly wage, right? H, what do you think H stands for here? Probably hour. So look here. If the mechanic works 0 to 40 hours, then he makes $14 times the number of hours. If he works overtime over the 40 hours, he would make time and a half. What is time and a half? $14 plus $7, which is $21, times that amount that is over the 40 hours or the overtime, plus the 560 that he got from multiplying 14 times 40. So that is where those numbers are coming from. It says evaluate W of 30. What does evaluate mean? Please remember that evaluate means you're substituting something for something, you're replacing something with something, you are plugging in something. So obviously, if W of H is equal to all of this, then we know that W of 30, that 30 represents the H. And we first go over to this side to see which interval 30 satisfies. 30 will fall into the first piece. Therefore, you will use only 14H. So 14 times your H here is 30. Put that in your calculator to get your 560. What about W of 40? Again, we are still in that regular work week. So we're in this first piece, 14 times 40. 30 should be, 14 times 30 should be 420. And 14 times 40 should be 560. So my mistake there. All right, what about 45? So now we're in overtime. H is greater than 40. So we are using the second piece now. 21 times 45 minus 40 plus 560 would be 21 times 5 plus 560, which is 21 times 5. That looks like 105 plus 560, which equals $665. All right. This is a good opportunity for you to pause the video to see if you can come up with W of 50. W of 50, H is 50. So 50 is greater than 40. So we have 21 times 50 minus 40 plus 560. Then we get 21 times 10 plus 560. 21 times 10 is 210 plus 560. So what we have, $770. Now, what if the company increased the regular work week to 45 hours? What would change what would change in this function here? If the regular work week was not 40 hours, they change it to 45. Now the workers are required to work 45 hours for a regular work week. What would change? Well, let's call this W sub 2H. All right. So one thing that would change over here on the right side, we know that it'll be that H will be between 0 and 45, right? And then we know at the bottom it would be the H would be greater than 45. We definitely know that. Would the 14H change at all? Nah. All right. 14H would not change. All right. What about 21 times H minus 40 plus 560? Well, definitely that 21 times H minus 45 now, right? Plus, what about what would you put for instead of 560, right? If it's 45 hours. All right. So we would change it because 45 hours will give us $665. instead. So that's how the weekly wage function would change if the company increased the regular work week to 45 hours.